Thank you. Good morning, and thank you for the introduction. While we are waiting for my presentation to show up, I can tell you a bit about my employer, RISE, Research Institutes of Sweden. We are owned by Swedish government. We are independent and non-profit research organization. RISE is kind of umbrella organization for several research institutes in Sweden. One of these is Victoria, where I work. And at RISE Victoria, we focus a lot on sustainable transports in general. We work on electrical, electromobility, automation, business modeling for new mobility services, and so on. And myself, I work a lot with automated and connected vehicles. And today I will talk about interactions between automated vehicles and other road users around them. So I will not focus on interaction between automated vehicles and passengers or drivers inside. I will focus on pedestrians, bicycles, drivers of manual vehicles that automated vehicles will interact with. About interactions with automated vehicles at all, will these interactions change when we have automated vehicles compared to what we have today? Well, today when road users interact with each other in traffic, we use a lot of signals to interact with each other. We use each other's speed, for instance, distance, but also we use body language. We look at eye contact, for instance, if you are a pedestrian and about to cross the road, if the vehicle is close enough, you look for driver contact. You look at eyes, you look at body position and try to figure out, have we understood each other? Is it okay that I cross or should I wait? But when drivers are not there in automated vehicles, we suspect that this interaction may change. It may look different in the future. How different? We don't know. That's why we are doing research in this field. And another question that has been quite relevant and is becoming more and more popular is if this new interaction, if it should be improved by adding some interfaces on the vehicle, something that is often referred to as external vehicle interfaces. So 2 questions. What will change in interaction, and could external vehicle interfaces improve interaction? And what do we mean by improve? Does it mean that we expect actual safety to improve, to reduce number of accidents? Or are we talking about user experience, how I perceive interaction? So one thing is to talk about accidents and incidents. Another thing is to talk about feelings, how people experience things. So it could be safe, but if you don't experience it as safe, it may not feel really acceptable. And acceptance is key for automated vehicles. Without acceptance in society, there will not be any automated vehicles. That's very simple. We can make technical solution more or less perfect, but if people don't like it, if people don't trust it, they will not accept it, they will not use it. So it has to do a lot with other things, not only the actual number of reduced accidents or avoided accidents. So I will try to give you just a quick overview of what we have been doing in this field at RISE. We started maybe 5-6 years ago addressing this topic, so we have done quite a lot of studies. However, basically 90% of our studies have been experiments, controlled experiments. The reason is we don't have automated vehicles in traffic, and it's difficult to do other kind of studies, but controlled experiments. We looked mainly on interaction with pedestrians in different situations, for instance, at zebra crossing, at parking lot, in garage. Parking lots are interesting because we don't have clear traffic rules there. People need to negotiate, people need to communicate with each other in order to figure out, should I go or should you go? We have been looking at interaction with drivers of manual vehicles as well, which you can see, for instance, here in this picture, here as well. So a few different traffic situations that we try to investigate and see, will interactions change here? So typically when we have done these experiments, we looked at interaction with regular vehicles that we have today, and then interactions with automated vehicles, and try to compare them and to see what is similar and what is different there. We have done this, of course, together with several organizations from industry. At RISE, we work a lot with industrial partners. So one of our very first studies, yes, that's me, 6 years ago, I think, we started by investigating this using a photo test. So we took a couple of pictures. The first one illustrating normal driving, something that we are used to see today. And then other pictures, especially the last one, illustrating a future where vehicle drives itself. So driver could be sleeping, or the driver could be reading newspaper. So we took these pictures and asked people, how would you feel if you met such a vehicle where you see driver is reading, where you see that the driver is sleeping? So it was very much subjective assessment of how people would perceive these kind of situations. Then next step, what we did was to fake automation. We took a right hand-steered vehicle, a British vehicle, and made it look like automated vehicle. So basically, my colleague Victor here, he's the real driver, and I'm pretending to be driving. So which means that I could read newspaper without causing any dangerous traffic situation. With this setup, we did several different studies where people could be in traffic or in a garage or a parking lot and interact with automated vehicle. So this is just a picture from a very first study. This is at Chalmers University in Gothenburg. Open street, but not very much traffic on that street. So we could do controlled experiment. And what we found here, that when people encounter driver where normal driving, the first one, it results in calm interaction. It's something that we are used to today, so no strange there. But then when pedestrians encounter driver talking on phone or reading newspaper, they perceive that quite stressful and unpleasant. And then if there was no driver visible in vehicle, that was even more stressful. Basically, as soon as the driver was not doing what we are used to today, people said, I would not cross the street. I would be more suspicious. I would wait and see until the vehicle is really standing still, and then I would go. And already here it tells a lot about how interaction may change. Because today it's easy, we look at the driver in distance or vehicle motion, and then we make decision, okay, it's okay to pass. But if you wait, then it may be interruption in traffic flow for pedestrians, if you need to wait for a vehicle to pass. From this kind of studies, we concluded that it may be useful that vehicle shows its own intentions to pedestrians. So we specified 4 different signals that vehicles should communicate to pedestrians and other road users around them. The first one to show that the vehicle is in automated mode. The other one is to show that the vehicle is yielding. The third one is to show that the vehicle is waiting or resting. And fourth one, to show when the vehicle is about to start driving again. And this was pretty much in line with some other studies using these driverless pods in Europe from a European project. So what we did, we derived several requirements on this interface, and one of the requirements was that it should be minimalistic. It should be possible to add on existing vehicle models. And the last one, it should not tell other road users what to do. It should only inform them about what the vehicle is about to do, and then it's up to each and one to decide, okay, will I cross or not? So that was one of the major requirements that we had. So this is the interface I'm talking about. You will shortly see a video. So 4 signals, I'm in automated mode, I'm about to yield, and I'm waiting, and I'm about to start driving. It's installed on windshield in this vehicle. So this is the signal here. It changes dynamically in these 4. So I will see if my movie works here. This is just one of the examples how such an external vehicle interface could look like. Nowadays, there are maybe 40 different examples of different external interfaces on automated vehicles. We did some evaluations with this interface. We went back to the same place, and basically what we concluded that people find interactions more easier and they feel more calm when they know that the vehicle is about to yield and so on. However, we concluded also that people need to learn what this interface means. So there is a learning process here. It's not very something that you easily know, oh, that means that a vehicle is automated. If you know it means the vehicle is automated, then it's easy to remember and interpret, but you need to know that. And that's basically one of the major challenges when designing this, because people don't know it's something new that we will have. We did some redesign of interface. I will not go into details. And then, as I mentioned previously, we studied it in different situations using different environments and different tools. And basically, as I said, our conclusion is that this kind of interfaces make interaction easier, but there are many challenges around it, how to design it and where to place it, in what format, and so on. And currently there is a group in ISO standardization looking in this and trying to figure out how should we do. Because if each vehicle manufacturer goes for its own interface, we'll have very different vehicles showing different information in different way and so on, and it will be very confusing for road users. So ISO is trying to find out a good way to make this standard. Now back to maybe something that is more relevant for what you have been talking here yesterday and previously today. This small self-driving buses, no driver. There is an experiment going on in Gothenburg. It started before summer in May, beginning of June. This bus was running at Chalmers University in Gothenburg, predefined route going back and forth. And now we are looking at extending this trial to Lindholmen in Gothenburg, if you are familiar with the area. Lindholmen is special because we have so much construction going on there. So we're looking at how could this type of mobility be integrated in when you create new city areas. So it has to do a lot of with city planning and other stakeholders that are involved with it. However, it puts a lot of challenges on the bus because there are a lot of things going on when you are constructing an area. So we are looking at how to make sure that this bus can be running safely. You can go in this web page and find out more information about the bus. You can see it's there running in front of Chalmers University. We did a user survey about this. We asked pedestrians, bicyclists, vehicle drivers, and so on, also passengers on the bus, how they perceive interaction between the bus and other road users around. This results shown in this graph are just preliminary. I think we have now at least double as much participants in the survey. Basically, we asked them how they experience interaction, and pretty much all of them were quite positive. They found this bus interesting, it was safe, it was not moving very fast. At the same time, that was the drawback of the bus, because they didn't see, it was not useful for them because it was running very slow. So they could walk pretty much in same speed as the bus. So that's something important to have in mind when doing that kind of trials. It's good for testing technology, but people may get wrong perception of the system and believe, okay, this is not useful because it's running too slow. So while we are trying to kind of find a balance between speed and safety, it could have negative effect on user experience. And by that, I think I will stop my presentation. Just a few words to sum up. We believe, based on our studies and studies done by other stakeholders in the area, that interactions that we are used to today will change in future when we have automated vehicles. But still, we don't know how much they will change. Will they change everywhere in all situations, or maybe only when the vehicle is really close to you? So we are highlighting that more research is needed on this, especially if we are talking about external interfaces. We don't want to introduce something on vehicles if it's not needed. So that's, I would say, very important to consider when studying this topic in future. Is this really needed? I don't know yet. Maybe next year I will know more.
Thank you very much, Azra. That was fantastic. Okay.
Thank you.